Hello and welcome to this video tutorial. My name is Glenn. I am currently a Senior Information and Computer Technology major at East Carolina University. I have developed this tutorial as part of my senior capstone project. I hope it enhances your understanding of Linux concepts.
Today we will be discussing RHEL as it pertains to Red Hat Enterprise Linux. RHEL stands for Redundant Array of Inexpensive Disks. RHEL is a method of combining hard disks into an array to increase speed, reliability, or a combination of both speed and reliability. RHEL levels are the different methods of disk combination. The RHEL levels that will be covered within this presentation are RHEL 0, RHEL 1, RHEL 3, RHEL 4, and RHEL 5. RHEL 0 is known as striping. With this style of RHEL, the data is striped or distributed across the array. This method of data storage increases performance at the cost of reliability. RHEL 1 is known as mirroring. In this style of RHEL, the data is mirrored between two or more disks. This creates a clone of the data. RHEL 3 utilizes striping, much like RHEL 0, but includes a parity disk. This parity disk is useful for rebuilding the array should one of the striped disks fail. RHEL 4 works nearly identically to RHEL 3. However, in RHEL 4, the disks operate independently of each other. This allows for a much greater I/O throughput. RHEL 5 is similar to RHEL 4, except for the fact that its parity is distributed amongst the array. This distribution allows for the array to be much more survivable than it would otherwise be. The mdatom command is the command within Red Hat Enterprise Linux that is used to create RAID volumes, or metadisks. The pertinent switches for the mdatom command are as follows. -C. This switch allows you to create a new metadisk. The -L switch allows you to specify the RAID level that you are implementing. The -N switch allows you to specify the number of devices that will be participating within the RAID array. The -X switch allows you to specify the number of spare devices within the array. The -D switch allows you to view the status of your RAID array. And now we will begin the demonstration portion of this tutorial video, where we will be creating a RAID device within Red Hat Enterprise Linux. The first thing we're going to do is take an fdisk-L reading of the devices available to us. We can see that we have a 1 gig second hard disk /dev/sdb right here. This is the hard disk that we will be using to create our RAID array. The first thing we are going to do is create partitions of this hard disk. For this, we will use the fdisk command. Fdisk and then /dev/sdb, and we will begin creating. Pressing M here gives us a helpful listing of the fdisk commands that are available to you. Since we would like to create new partitions, we are going to be using the N command. So we will press N. We will begin creating our primary partitions, so P. And since it is the first partition, we will use partition number 1. We would like to leave the first cylinder the same, so we press Enter. We would like to create this in a size of 128 megabytes, so we do plus 128 capital M and press enter. We have now created a new partition. If you press P and hit enter, you can now see the new partition there listed in the partition table. Now let's create our other partitions. All of the partitions we will be creating today will be of the size 128 megabytes. Now that we have hit our third primary partition, we are going to create an extended partition because we would like to keep going beyond just 4 partitions. So we'll press E, and the entire 4th partition will take up the rest of the available space on our hard disk, so we will just press enter throughout the process. And now, as we take a readout of our partition table, you can see that we have /dev/sdb1 through 4 available. And now we will add the rest. All of the rest of the partitions, you can see, will begin at the beginning of the extended partition. So this first extended partition will begin on the 52nd cylinder. We'll press enter. Again, we are using 128 megabytes. If we press P again, we can see that we have 2 new available usable partitions, /dev/sdb5 and /dev/sdb6. Now that we have created these, we have to specify which type of partition they are using the T command. We'll start with partition number 1, and the hex code we are using is going to be FD, which creates a Linux RAID partition. But if you would like to see all of the available hex codes, you can simply type the capital L and press enter and look through all of the hex codes to decide which one best suits your needs. We use FD for our Linux RAID, and now we will continue on through the rest of the partitions. Do a printout of the partition table, we now see that all of the partitions that we are going to use are now Linux RAID type partitions. Now, we would like to save our partition table, so we're going to use the W key, and it will now save the partition table to /dev/sdb. We do an fdisk-l, we now see all of our partitions. Alright, now that we have created these new partitions, we are going to use the partprobe command to inform the operating system of changes to the partition table. Now, we are going to use the mdatom command that we learned earlier to create our RAID array. So we're going to do mdatom-c /dev/md0. The number of devices is going to be 4. I'm going to use /dev/sdb1 /dev/sdb2 /dev/sdb3 /dev/sdb5. Alright. We're going to use one spare device, which is going to be /dev/sdb6. This is going to be a backup device should we have a device fail. And we are going to do level 5 of RAID level 5. Alright, now as you can see, we have successfully completed that, and if we do an fdisk-l readout, we can see that the device MD0 is being picked up by Red Hat, and if we do mdatom-d/dev/md0, you can see that it is setting itself up. You can see up here under state where it says clean, degraded, and recovering. That means the RAID array is synchronizing data across all the disks and setting up the parity for in case something were to be wrong. The rebuild status is right here. As you can see, it is 27% complete at the time of this command. And if we run it again, you can see that it has increased its completion status. We have 2 spare devices here, /dev/sdb5 and /dev/sdb6. Once the array has finished rebuilding, I will demonstrate what occurs when a device fails and how you can view that a device has failed and what will happen once the device fails.